All right, welcome to week 3 of the practice problems for the ACT Math Prep course. Let's get started. All right, it says a shoe store is offering a 15% off sale on all shoes. What is the discounted price of a pair of shoes that originally cost $48? All right, so $48 is our original price. All right, so if I want to know the discount, I just need to find 15% of that $48. Okay, now be careful. Some of these problems tell you that the new price is $48, and to do that, we would do it a little bit differently. Basically, I want to know what 15% of $48 is. So 15%, remember, you always convert that to a decimal, or remember that 15% means 15 divided by 100, 15%, but that gives you 0.15. It's the same thing. Of means multiply and 48. So if I pop out my calculator here, I do 0.15 times 48. I'm going to see what my discount is. So my discount is 7.2. Remember, we're dealing with money, so 7.2 means $7.20. That is my discount. Okay? Now, what does the question actually say? What is the discounted price? So we want to take that discount away from the $48. So we're going to do $48 minus $7.20. That's going to give us $40.80. So we are going to go with choice D. All right. Pretty straightforward problem there. All right, next problem. A $400 computer is discounted by 15%, and the price of a $150 printer is raised by 20%. What is the difference in the cost of the two items after the price changes? All right, so we've got a computer that's being discounted 15%. So we want to take that $400 computer and we want to subtract whatever the discounted price is. So we want to subtract 15% of $400. Okay, we're just taking away the discount. So remember, you can actually use your calculator, or you can do this pretty quickly. Actually, 10% of 400 is 40, because we just moved the decimal over one place. That means 5% should be half of that. 5% should be 20. Total of 15%, making a total of $60. So if I take away 15%, I'm going to end up with $360. So that's the new cost of my computer. Okay, that's the new cost of my computer. Now, if I deal with the printer, I'm talking about $150, but raising it 20%. So I'm going to do, actually, before I do that, I wanted to show one thing here. This whole process of taking away 15%, remember 15% less would be 85%. Right? If you took 100% and you subtracted 15%, you get 85. So you could alternately do $400 times 0.85. Okay? If you do $400 times 0.85, it does all that subtraction for you. It gives you 340. Sorry, yes, obviously, let me rewrite this here. This 360 should be 340. Yeah. But do you see what I'm saying? I can take the original and subtract away the discount, or I could just remember that the discounted price is just 85% and then do that multiplication here. It kind of works out the same way. So let's try that same method with the printer. So the printer is $150. We're going to raise it 20%. That means it's going to be 120%. So if I just multiply this by 120%, or in other words, 1.2, I should get my new cost. So let's try that on the calculator here. 150 times 1.2 gives me 180. All right, so that is the new cost of my printer, so $180. So the question ultimately says, what is the difference in cost between the two items? So the difference is basically the distance between these two numbers. And the way we find distance or differences is we subtract. So 340 minus 180, that's going to give me 160. So my answer that is correct is choice B. Okay. All right. A recipe calls for cooking a chicken 30 minutes for every 2 pounds it weighs. If a chicken weighs 15 pounds, how long should you cook it? All right, so this is going to be a proportion problem because we look at the ratio between the time it cooks and the weight of the chicken. Okay, that proportion should be the same no matter how big the chicken is, right? The bigger the bird, the longer it should cook. The smaller the chicken, the less time it should take to cook. So that means it's proportional if it's changing in the same amount. So let's look at the ratio here. So first of all, I'm looking at time, but it says 30 minutes. All my answers are in hours. So I think I actually want to convert 30 minutes to hours. So 30 minutes is half an hour. Okay, and in the recipe proportion, it says 30 minutes, 2 pounds. Okay, that's where I get that 0.5 hours and 2 pounds. That's the recipe proportion. But excuse me, the recipe ratio. That should be equal to the actual chicken that I'm talking about cooking, but it should be the same ratio. So time over weight. So the time, I don't know the time, but that's what the question's asking. It's saying how long should I cook it? When I don't know something, I always use a variable there. We're going to divide that by the weight of the chicken, which is 15 pounds, and we've set up our proportion. Remember, always when you're setting up proportions, the way to solve them is to just cross multiply. 2 times x is 2x. That is equal to 0.5 times 15. Half of 15, 7.5. And totally could use a calculator there if you weren't sure. All right, last step is to divide by 2. X is equal to half of 7.5, which is 3.75. That is in hours, so we're looking at choice E for our answer. All right. Next question. The 2 triangles in a given picture are similar. The side lengths are marked in feet. What is the value of X in the picture? So, all right, so this one, they tell us that they're similar figures. So we know with similar figures, we're dealing with proportional reasoning here. So I can look at the small side over the big side. That should equal the other small side over the big side. Okay, so I'm going to look at the ratio between the small and the big. So in the left triangle, the ratio of small to big is 2 and 3, 2 to 3. That should be equal to the ratio of x to 8. If they're proportional, excuse me, if they're similar, they're proportional, and that should hold true. So we cross multiply. 2 times 8 is 16. 3 times x is 3x. Divide both sides by 3, you get 16/3. Now that answer is not any of our choices. A couple ways to think about this. Just divide 16 by 3. Okay, you have 16 items, you divide it into 3 groups. Everybody gets 5, and there's 1 left over, and I have to divide that 1 by 3 people. And when you divide 1 by 3, you get 1/3. Okay, now alternately, if you weren't sure about that at all, okay, go over to your calculator, do 16 divided by 3, you're going to get this decimal answer. Now, it's 5.333, and here the only thing with a 5 anything, is 5 is the whole number, is C, so it's got to be C. But let's say there were a couple other choices. You could actually convert this number into a mixed fraction by doing alpha y equals, and you want to do as a fraction first, so you want to do number 1. Oops. All right, let's try this again. You want to do 16 divided by 3, and what you want to do is you actually want to convert that as number 3 from a numerator denominator to a mixed number. Actually, I have to try that again. Sorry. Let's try it one more time. Alpha y equals number 3 is going to convert our answer, which is a fraction, into a mixed fraction. The u just means the whole number there. So I guess you technically have to convert it into a fraction here. It doesn't recognize that as a fraction. So anyway, that's one way to do that problem as well. All right, moving on. The car is discounted 6%. The new price is $7,050. What was the original price? Okay, for this problem, they tell us the discount and they tell us the new price. They don't tell us the original price. If they told us the original price, we'd just subtract 6% from that. This has to be a little different. So what we do is the original price minus the discount. Oops. equals the new price. Now remember, when we want to find the discount, what we do is we multiply the original, excuse me, the original times, what would it be if it was 6% discounted? What percent would you say this is? If it's a 6% discount of the original price, then it's a 94%. So basically, we know that 94% of this original number gives us 7,050, okay? Now remember, we never deal with percents like that. We always convert them to decimals. So some number times 94% is going to equal 7050. So all we got to do is solve for x here. So we're going to divide by 0.94, divide by 0.94, and we get x is 7050 divided by 0.94. So 7050 divided by 0.94 gives us 7,500. So our answer is A. Now, this would have been a good choice where you can work backwards, like that testing strategy we learned in week 2. You could have picked B, and you would have seen that B was too much. If you took B, right, this 7550, and you multiplied it by 94%, which is a 6% discount, you would have seen that your answer was too big. So you would have known that the answer has to be smaller. So with only choosing one guess there, you would have known it was A. So that testing strategy really could have been useful here as well. All right, next problem. The map shows a rectangular building that is 2.5 centimeters by 3 centimeters in size. If a 5 centimeter square on the map represents an actual building that is 40 feet squared, what is the measurement of the smaller side of the rectangle in feet? Okay, so this is a scale problem, and these deal very much with proportions. So you've got this small map. It shows a 3 centimeter side and a 2.5 centimeter side, and it's similar to this actual building, okay? Now, we don't know these sides here, but we only need to know one of them. It just asks for the smaller side. So really, we're only concerned with this 2.5 and this unknown amount here. And I remember we do have some comparison here. We know that a 5 centimeter building on the map translates to a 40-foot side of an actual building. So that's how we're going to set up our proportion. We know how that changes, and so we'll be able to tell how this changes. Okay, so we set up 5 over 40. All right, we'll do map over actual equals map over actual. Now, a couple things to notice here when you're working a problem like this did you notice that it's 8 times as big? Right, that means the scale factor is 8. Now, technically, since it's centimeters to feet, it's actually a different number. But just as far as the numbers go, it's 8 times the number. So our answer should be 8 times the number. So if you just did 8 times 2.5, you'd also get the answer. But I'll go ahead and show you how to solve this proportion. Another thing, when I set up the proportion, do you see how this is half as big? Well, this number should be half as big. So that tells you the answer as well. But let's go ahead and work it out. 40 times 2.5 is equal to 5 times x. I go ahead and divide this by 5, and that will give me x. So I got to get out my calculator here. All right, I do 40 times 2.5. And whatever that answer is, I divide by 5, and I get 20. So the answer to this question is D, 20. Okay. Next problem. From a survey of 3,450 people, 40% had no pets. How many people surveyed had pets? All right, so we know there's 3,450 people in this survey, and we know that 40% of them had no pets. So that means the rest had pets. So what would the rest be? If we've already talked about 40%, it's got to be 60% that have pets. So really, all I need to do is find 60% of this number. Okay, so I want to know 60% of 3,450. Remember, 60% is 60 over 100 times 3,450. Now remember, 60 out of 100 is just 0.60. Okay, so when I use my calculator here, I'm going to do 0.60 times 3450. I'm going to delete that negative sign I just added. 27. All right, so our answer is C, 2070. Now let's say you were working this problem and you noticed that you wanted to find the number of pets. Well, you just do 40% of 3450. Okay, so what if you had done that? What if you found 3450 times 40%? Right, that's 40% as a decimal. You'd have got 1380. You just got to make sure that you subtract 1380 from 3450. Now remember, when I'm using my calculator here, if I want to input that number that I just had as an answer, I can use second subtract or second minus sign, that ANS is answer. So when I do that, that ANS is 1350 or 1380. I get my 27. So either way it works. All right, of 330 people that work at a certain company, 220 of them haven't missed a day of work. What percent have missed at least one day of work? Okay, so this is sort of like the last one in the sense that I've got this amount that I know did something, and I'm actually trying to find the other piece, the people that did not do that. So that means if 220 didn't miss a day, that means 110 missed. Remember, I just did 330 minus 220. That gave me 110. So I want to know what percent have missed at least one day of work. So what I want to know is 110 is what percent of 330. That's the number sentence that I can create here. Okay, so 110 is, that's our equal sign, what percent? So x divided by 100 times 330. That's a times symbol there, not a decimal. Okay, so I just worked this thing out. A couple ways to do this. I could go ahead and get rid of the 330, right? That's being multiplied, so the opposite there would be to divide by 330. That will ensure that that cancels out. Okay, now all I've got to do is get rid of that 100. The way I get rid of that 100 is find out what's happening. How is the 100 being operated upon the x? Well, it's dividing by 100. So to get rid of the dividing by 100, I have to do the opposite, which is multiply by 100. So I'm going to multiply both sides by 100. That leaves me with 100 times 110 divided by 330. So I'll get out my calculator. 110 divided by 330. And I do that times 100. Now remember, I can just move the decimal over twice, but that's 33 and a third. Now, notice how that's all in decimal form and none of these are in decimal form. I need to convert this to a mixed number. It's not terribly difficult. Remember, I do have to go through making this a fraction. So if I did alpha y equals and number 1 says turn it into a fraction. Excuse me, that's not right. I want to do math, enter. There we go. That turns the answer into a fraction. Now, if I go to alpha y equals number 3, turns that from a fraction into a mixed fraction. So 33 and a third. Those are just some shortcuts there if you're not feeling really comfortable about those. But all right. So we get our answer B, 33 and a third. Now remember, this one's very similar to the last one. If you had done 220 out of 330, you would have gotten 66 and 2/3%. Just remember that that's the percent that we don't want. So you would take that away from the total, and the total is 100%. So if you had done 100% minus that amount, that percentage of people that hadn't missed work, you'd find the rest, which have missed at least one day of work. Okay. All right, in a triathlon, I swam 20 miles in 2 hours. I biked 10 miles an hour faster than I swam. I biked for 2 hours total. Finally, I ran 6 miles per hour for 3 hours. How far in total did I travel during the race? Okay, so this is a mixed rate problem. We've got 3 different sections in this race. So what we got to remember is that the total should equal part 1 plus part 2 plus part 3. Okay, and whatever it is, the distance, or the time it took. That's what I'm talking about. The total should just equal the 3 parts combined. Now, what does the question ask? The question asks, how far in total did I travel during the race? So that question is asking me for distance. So that sounds like the distance that is in total here should equal the distance from the swim plus the distance from the bike plus the distance I ran. Okay, so the total distance should be just the sum of those 3 things. So all I got to do is figure out the sum of those 3 things. Okay, first part says I swam 20 miles in 2 hours. Okay, so how far did I swim total? It's tempting to say maybe 40, but remember, it's not 20 miles per hour. It's just 20 miles total. It just took me 2 hours to get there. So I think that means that the first leg of my race was 20 miles. Okay. Second thing says I biked 10 miles an hour faster than I swam. Okay. Well, how fast did I swim? It doesn't tell me. But if I remember this formula, distance equals rate times time, or rate equals distance divided by time. These are very important that we know these, for especially for these rate problems. That's going to help me figure out my speed. So we're going to use the second formula because we want to know the rate. I want to know how fast I swam. So I can add 10 miles an hour to that to find out how fast I biked. Okay, so when I'm talking about swimming, the distance was 20 miles, the time was 2 hours. So the rate at which I biked was 20 miles divided by 2 hours. Now we always want to reduce this fraction to 20 divided by 2, which is 10. So that's going to be miles per hour. Okay, that's the rate at which I swam. I'm sorry, this is swim. The rate at which I swim was 10 miles per hour. Okay, so if I bike 10 miles an hour faster, that means the rate at which I biked was 20 miles per hour. Okay, now it does say that I biked for 2 hours total. So if I go 20 miles per hour, how far would I go in 2 hours? Yeah, I'd go 40 miles. So that's my second part. Okay, I had to figure out that rate before I could actually calculate the distance I traveled. Finally, it says I ran 6 miles per hour for 3 hours in the run section. Now that's pretty straightforward. I know the rate and I know the time. So look at my first formula here. Distance equals rate, that's miles per hour, times time, 3 hours. So 6 times 3 gives me 18. That means that I swam for 20, biked for 40, ran for 18. So the sum of those is 78 miles, which is where I get D as my answer. Okay. Key to this problem is knowing that the total is part 1 plus part 2 plus part 3. When things are happening at different speeds, at different distances, different times, you always just remember that the total is each part added together, and you can set up a formula or an equation. All right, 85 is 20% of what number? All right, this is a simple word, number sentence that we have in words. We just need to convert to an equation. So remember our conversions here. 85 is means equals 20%. That's 20 divided by 100. Of means multiply, and number means x. So really, I can convert that 20 over 100 to a decimal. It's just 0.2. So 0.2 times x is 0.2x. That's equal to 85. All I got to do is divide that out, and I get my answer. So pop over my calculator. Got to do it in order. 85 divided by 0.2. 85 divided by 0.2 is 425. That is our answer. Now remember, does this number make sense? 85 is 20% of what? Well, 20% is like a fifth. And a fifth of 400 would be 80. So a fifth of a little more should be a little more. That makes sense. So it's good to check that. Remember this step here, this 20 divided by 100, when you see 20%, remember percent really means divided by 100. If it says X percent, then you have to do X over 100. But if it says 20%, you can actually rewrite that immediately as a decimal. Usually it's easier to work with one number Alternately, if I didn't see that I could just divide that out, I could have multiplied by 100. Remember, that would have gotten rid of the dividing by 100 part. That would leave me with 8,500 equals 20x, and then I would divide out the 20. Either way, I'm going to get the same number. But that's just a little bit of a shortcut there. If you can realize 20% is just 0.2, that'll save you just a little bit of time. All right, what is 12% of 225? Okay, so this is another number sentence that we want to make. So what is? What always means the unknown, the variable, x. Is means equals 12% of 225. Remember, you can also write 12% as a decimal, but this is a pretty straightforward problem. We just need to find 225 times 0.12. It gives you 27. Okay, so we know it's B. Now let's just try some other things out here. Let's do 12 divided by 100 first, and then multiply that by 225. Obviously, it's the same thing. What if you like the fraction? What if you want to make it look just like it does on paper? You see how it looks on paper? 12 divided by 100 times 225. You can do that. Alpha y equals is where your fraction is. And you can do 12 divided by 100. Then just multiply that by 225. You'll get 27 either way. So there's a couple different ways. That's all preference. Got to just pick whichever way you like the best. But remember, the whole key here is just writing it in an equation from words, converting it right directly into an equation. Does 27 make sense? What's 10% of 225? 10% is 22.5. So we're looking for 12%. So that would make sense why 22 can't be the answer, because that's less. 112 is more than half. Oh, well, it's just about half, so it's more like 50%. So there's a couple things you can eliminate. Remember, if you can eliminate choices, that always helps. All right, the ratio of boys to girls in a school is 2 to 5. If there are 360 girls, how many students are there in the school? All right, so the ratio is 2 to 5. Does that mean there's 2 students that are boys and 5 students that are girls? It could be. There could be, if the ratio of boys to girls is 2 to 5. It's possible that there really are 2 boys and 5 girls. That is possible. Okay. What if there was double that, though? What if there was 4 boys? There would be 10 girls. Okay. What if there was 200 boys? There would be 400 girls. All these numbers are in the same ratio of 2 to 5. 2 to 5, 2 to 5, 2 to 5. Okay. Ratios are kind of like a reduced fraction. So what we know is that the ratio is 2 to 5. We can write it vertically. We know the ratio should be proportional. Okay. So if there are 360 girls, think about this, is girls on top or bottom? Said girls was 5. That means girls is on bottom here. So that means when I set it equal, I should have girls on bottom there. Okay. Now remember, when I solve for x, what am I actually finding here? This is the number of boys. Okay, we got boys over girls equals boys over girls. So x is boys. The question does not say how many boys are in the school. But you'll notice something when I solve this, that's probably going to be one of my answers. It's very likely. Those are called distractor answers, and they like to put those on there. They want to try to catch you in a mistake. So 5 times x is 5 times x. Remember, we just write that as 5x. 2 times 360 is 720. Divide out the 5. Here's a little tip for you. Dividing by 5 is like dividing by 10 and multiplying by 2. So if I do 720 divided by 10, I get 72. And then if I double it, I get 144. Is that right? 72 times 2 is 144. So x is 144. Now, they did not have that in the answer, but it's very possible that that could be one of your answer choices, that 144. They want to catch you in those mistakes. So be careful of that. X is not what I'm looking for. That's just the number of boys. Okay. What I want to know is the total number of students. So the total number of students is that 144, which is my boys, plus my 360, which is my girls. So I should get 504 total students. Okay. Now, sometimes, okay, there's like little shortcuts to this. Okay. 2 to 5 is 360 to something. Okay. What you basically have to see is what number did I multiply 5 by to make it 360? Okay, well, you could do 360 divided by 5. That would be 72. So then what you could do is multiply. If you multiply by 72 to get this number, you'd also multiply by 72 to get this number. That means it has to be 144. Really, that's what you're doing when you cross multiply. But this kind of, sometimes people like to think of it this way. This might be called the scale factor, that's 72. All right, cooking a batch of cookies requires 1.5 cups of flour. If one batch makes 16 cookies, how many cookies can I make with 18 cups of flour? Okay, so this is definitely a recipe problem that involves proportions. So we can look at the ratio between flour and the number of cookies. Okay. So the ratio of the one batch should be the same ratio as the entire batch that I make with the 18 cups of flour. So looking at the one batch, I have 1.5 cups of flour, okay, and I'm making 16 cookies. So that ratio should equal the ratio when I don't know the number of cookies, but I know that I have 18 cups of flour. So what did I do wrong here? I've got flour on top, cookies on bottom right here. But did I do that over here? I didn't. So instead of x over 18 like I had, I should have done 1.5 over 16. Flour over cups equals flour over cups. Okay, you got to make sure you do not flip those because that will give you the wrong answer. This is a very simple problem. It's proportions, so we cross multiply, okay? 1.5 times x equals 16 times 18. I get on my calculator, 16 times 18 is 288 times 1.5x. Divide both sides by 1.5, and you get our answer of 192. Okay, which makes sense in our problem. Got a lot of 1.5 cups of flour. How many did I have? So 1.5 cups, if I turn it into 18, 10 1.5s is 15, and it takes 2 more 1.5s, because that would be 3. So there's 12 total. So I did 12 times as many batches. So that's why I should do 12 times these 16 cookies. So I have 12 times 16. That's where I get 192 from. All right. Actually, I want to go back to this. There are some times when you have problems where, let's say there's a tree and the tree grows 20 feet. When it was smaller, its shadow was 18, and now its shadow is 24. Okay, question is, how tall was the tree? I'm trying to write 2 words at the same time. How tall was the tree? Okay, so on this one, the tree was 20 and now it's 120. So we've got this ratio of the old tree, and then we got a new tree, and we're looking at the ratio of the height versus the shadow. Okay, so the height of the old tree, well, we don't know what it is, so we'll call it x, over its shadow, which was 18, should equal the new tree. Now it's tempting to try to put y, a different variable, because it's a different amount. But you always want to try to use as few variables as possible. So if you can compare this to what it used to be using the variable x, which we can actually write an expression for the new height. So since it grew 20, I'm going to say x over 20. Okay, and now its new shadow is 24. Just want you to be aware that this is possible. You can still cross multiply. 24 times x is 24x. Now here you have to multiply this 18 to both parts. You have to distribute because there's now a group. But if you do 18 times x, you get 18x plus 18 times 20, which is 360. And you just solve that equation, right? You subtract over your 18x from both sides, you get 6x equals 360, so x is 60. So the tree was 60 feet, now it's 80 feet. So you can answer any of those kind of questions. But just be aware that sometimes you have more than one x in the problem, and you treat it just the same. You cross multiply. Never change the way. When you have a fraction equal to a fraction, just cross multiply. Alrighty, on the first part of the trip, Bill drove 60 miles per hour for 2 hours. He stopped for gas, which took 15 minutes. On the second part of his trip, he drove 40 miles per hour. If the trip total was 300 miles, how long did it take to drive the entire trip, including driving and gas stops? All right, so this is a thing where it breaks it up into little pieces. So the total time, remember I'm talking about time because it does say how long did it take, and all my answers are in time. So I want to say the total time equals the part 1 plus the break plus the part 2 of the trip. Okay, you took that little gas break. All right, so we're talking about time. I'm given 60 miles per hour. So they give me a rate equals 60 miles per hour, and they give me a time, which is 2 hours. Okay. Now, if we're talking about the total time, they give me the first leg of the trip. It was 2 hours. So I know the first part was 2 hours. Plug that in directly. It also tells me that the break was 15 minutes. Now look at my answers. See how they're all in decimal form? We actually got to be really careful when we're dealing with decimals and time, because 4.5 hours is 4 hours and 30 minutes. So 30 minutes is a half of an hour. You got to be really careful there. Okay. Now what fraction of, or what decimal I should say, or what fraction of the whole hour is 15 minutes? It's 1/4. Remember, 1/4 is 0.25. So we're going to say 0.25. Okay. Now all we got to do is find the third leg. So the third leg, it says he drove 40 miles per hour. Okay. So I have a rate. Do I have a distance? No, I don't have a distance. And I don't have time, which is what I'm actually looking for here. So we have to think about this problem. It does say the total trip was 300 miles. So what if we think about this in miles? So the miles in total was the miles for the first part plus the miles on the second part. Now, why aren't we talking about the break? Well, you didn't really move then, right? So if I could find the distance and I know the rate, I could find the time. Remember, because we know distance equals rate times time, which means that time is just the rate, the distance over the rate. So I could find the time if I knew the distance and the rate for this third leg. So I'm about to find the distance. I already know the rate was 400 miles per hour. So this is sort of a tricky problem that you got to really think through. This is a problem-solving problem. So the total was 300 miles. It should equal the first part. It says he drove 60 miles an hour for 2 hours. Okay, again, think of this distance equals rate times time. The rate was 60 miles per hour. The time was 2 hours. You multiply them, you get 120 miles. So again, we're still using that distance times rate, or distance equals rate times time. Plus m. We don't know what m is, but we can calculate it, right? Subtract 120 from both sides, gives me 180 miles. So that tells me that third leg was 180 miles. So the distance is 180 miles. Remember, this is for the third leg. And we also know that he went 40 miles per hour. So if we use our formula, time equals distance over rate, we take the distance, we divide it by the rate, we're going to get the time. 180 divided by 40 is going to be 4.5. Okay, 4.5 hours. So I add that here, 4.5 hours. My total is 2 plus a quarter plus 4.5. That gives me 6.75 hours. So E is my answer. Okay, tricky problem. Jill can yeah, if Jill can wash a car in 2 hours and Terry can wash the same car in 3 hours, how many cars can they wash in 12 hours if they work together? All right, so this is definitely a mixed rate problem. Now remember, they're doing something per hour, 1 car per hour. So we're saying 1 car per time unit, okay? So for some number of hours there. So this is going to be 1 over the time equals 1 over the time plus 1 over the time. So this is for Jill and this is for Terry. Okay, they're doing 1 car per number of hours, 1 over number of hours, 1 car per number of hours. So when you hear the word per, you kind of almost have to add in that word per because it's not technically in there, but they're doing 1 car per 2 hours, right? She can do that. He's doing 1 car per 3 hours. So when you add that word per in there, it makes it a little more clear why we're dividing. Okay, so remember, this is the total time. So what do we know? We know she can do it 1 car per 2 hours. So she can do 1 car per 2 hours. He can do 1 car per 3 hours. And we're able to calculate the total time they can do it together. That's why we're adding, because they're doing it together. Now, if I can tell you how many they can do 1 car in a certain amount of time, I can calculate that time. That doesn't answer my question. I want to know how many cars can they wash in a certain number of hours. So we'll have to do a little more work once we solve this. A couple options here, 1/2 plus 1/3. You can convert these into common denominators of 6. If I multiply both of these by the same number on top and bottom to where I get a common denominator in my fractions, it's actually pretty easy to do now. So 1 over x is 5/6. Remember, this would be really easy on your calculator, 1 over 2 plus 1 over 3, and then make it into a fraction. It's pretty easy. Here I have to cross multiply. 5x is equal to 6. If I divide by 5, I get 1.2, which tells me x is the number of hours it takes for them to work on this problem together. So together they can do 1 car in 1.2 hours. So 1 car in 1.2 hours should equal the number of cars they can do, which we don't know, over 12 hours. So now we set up a proportion to solve this, okay? Cross multiply, 1 car times 12 is 12, should equal 1.2 times x. We divide by 1.2 on both sides. 12 divided by 1.2 is going to be 10, okay? So our answer is E. All right, next problem. A tall building is 450 feet tall. Standing next to the building, my shadow is 1.2 feet. If I am 5.8 feet tall, how long is the building's shadow to the nearest foot? All right, so we're talking about shadows. Basically, what happens is we build this diagram, right? It's not a tree, it's a building. I'm so used to seeing trees in these ones. So we have a building, and it casts a shadow here. Okay, the shadow, it says we don't know, we're trying to find it, but we know the building is 450 feet tall. And then you've got this other triangle of this person. They are 5.8 feet tall, and their shadow is 1.2 feet. Okay, these are similar triangles based upon the angle that the sun casts its rays. These are technically similar figures, so we're able to say they're proportional, and so we can use this reasoning. So we'll do the height over the shadow equals the height over the shadow, okay? You could do shadow over height or height over shadow, it doesn't matter, but as long as you're consistent, you don't want one of them to be upside down. So I'm doing the height over the shadow equals the height over the shadow. If you decided to do shadow over height equals shadow over height, cool as well. You can also do the shadow over the shadow equals the height over the height, but I just don't teach it that way. Nothing wrong with it. Just make sure you're consistent. If you do the shadow of the person over the building over the height of the person over the building, it's just got to match here. It's got to be person over building equals person over building. You can't get those mixed up. All right, so cross multiply 5.8x equals 450 times 1.2 divide out the 5.8, and you're going to get your answer. Pretty simple. Use a calculator to do this one. 450 times 1.2, and then divide that by 5.8. Notice how I'm hitting enter each time. You get 93.10. The question asked to the nearest foot, so you have to round. 93.1 is closer to 93 than it is to 94, so we're going to go with 93 as our answer, so C, 93. Now, real quick thought here. Why am I hitting enter there when I do, basically when I do this part right here? Why don't I just type it all in? Let's look, 450 times 1.2 divided by 5.8. Okay, it actually gives you the same thing. It's just a preference. Remember, alternately, you could do something like this. Use alpha y equals number 1 and make it into a fraction. And you can do 450 over 5.8. And then maybe on top, actually do your multiplication times 1.2. That way it looks just like what you wrote down. Sometimes that makes people feel better about it. But either way, you're going to get the same thing. So, all right, moving on. If the sides of a rectangle are 560 and 650, what is the area of the rectangle written in scientific notation? All right, so we've got a rectangle that is 560 by 650. So remember, area is length times width. So 560 times 650. Okay, we get out the calculator. 560 times 650. Get this big giant number, 364,000. 364,000. Don't forget where the decimal lies there. Remember, we are going to always write one number in front of the decimal every time when we do scientific notation. Question is basically 1, 2, 3, 4, 5. It moves 5 spaces. Is it a -5 or +5? I think that's the number one issue people have. Well, think about it. This big number moved to a very small number. So to make sure it stays the same, we're going to multiply by 10 to the +5th power. Sorry, I was writing the 5 there. Because we want to counterbalance that. All right, 3.64 times 10 to the 5th. 3.64 times 10 to the 5th is B. Now, let's see about this. If I go to mode, there is a scientific notation mode here, okay? And if I get out of here with second quit, and I do 560 times 650, I hit enter, it's going to give me the answer actually. So 3.64 times 10 to the 5th. You just got to remember that times 10 to the 5th, calculator won't do it. It'll just say E5. So if you remember that, that's really cool. Super easy way. It just takes a second. Go to mode here and make sure you're in scientific mode. Okay, make sure you go back. I mean, you'll know pretty quickly, but all right. Remember, second mode is how you get out of anything. If you're ever somewhere crazy on the calculator, second mode, that's quit. That will get you back to where you need to be. All right, what is the difference between 2.64 times 10 to the 1st and 3.3 times 10 to the -2nd? Okay, so what is the difference between 10 and 3? 7. How'd you get there? Subtract. So difference means subtract. So basically what we're doing is we're going to subtract this number from this number, okay? Remember, anytime you multiply by 10 to the 1st, all right, 10 to the 0 is 1, and that doesn't change anything. When you multiply by 10 to the 1st, you're multiplying by 10, so the number gets bigger. And remember, we just moved the decimal over one place when it's powers of 10. If you were to multiply by negative numbers, remember the number gets smaller, so we move to the left. So this number actually becomes 26.4 minus, I'll add a couple zeros here, 3.3 becomes 0.033. So basically we're doing 26.4 minus 0.033. So I can hop over to my calculator. I've already got that here. 26.4 minus 0.033. You get 26 26.367. 26.367. That's not in scientific notation, but I can make it in scientific notation by making the number smaller and then making this number big by the factor of however many numbers I move the decimal. So if I move the decimal 1, it's going to be 10 to the first. So that gives me choice A. Now remember, your calculator has that mode, right? If you go to second mode, if you just go to mode, not second mode, go over to scientific, you could do this pretty easily. You could do 26.4 minus 0.033, hit enter. It's going to do that for you, right? It gives you that e to the 1, which means times 10 to the first. So just remember that scientific mode on your calculator. It's not going to save you from bombing the test, but it could help you on a few things. So, if it makes you faster on this, it gives you extra time for something else that maybe is more difficult. That's what we want. All right, next problem. If my best time for running a mile race was 6 minutes, then after a year of training, my best time was 5.5 minutes. What is the percent decrease rounded to the nearest tenth? That's an 18 there on E, 18%. It's kind of hard to read. All right, so we're talking about minutes. We're talking about percent decrease. So remember, the formula is the change, either up or down. It doesn't matter. You just leave it as a positive, either up or down, over the original amount times 100. So the change was a half a minute, right? It went down half a minute over the original times 100, okay? Really, the trick here is just knowing that formula. So 0.5 divided by 6 times 100, 8.33. So rounded to the nearest tenth, that's going to be 8.3. Okay, don't forget, it doesn't matter that it's not negative. It did go down. If it said, what is the percent change, you would want to make sure that was a negative number because you did go down, which would just make that a negative 8.3%. All right, how many miles per hour did I go if I drove a motorcycle 12 feet per second, round to the nearest whole number? All right, so I've got 12 feet per 1 second. It doesn't say 1 second, but it kind of is implied that it's just 1 second. Now I'm going to end up in miles per hour. Okay, so I want feet to go away, so that means I need to put feet on the bottom. Now, what do I want on top? I want it miles on top. So I actually do miles on top here. And remember, this is going to work because I do know the conversion between miles and feet. 1 mile is 5,280 feet. Okay. Now remember, that's going to cancel the feet and leave me with miles on top, exactly what I want. Now seconds on the bottom isn't what I want. I want hours on the bottom. So I put seconds on top. Now I know the conversion between seconds and minutes. 60 seconds is 1 minute. Now what's going to happen to seconds? Seconds is going to cancel and minutes is now on bottom. So I'm 1 step closer. I want minutes to go away and I want hours to be on the bottom. So 60 minutes for 1 hour. Notice minutes will cancel. So now I've got all the things set up. I've got 12 times 1 times 60 times 60. And on the bottom, I've really just got 5280 because it's times 1 times 1 times 1. This will be in miles per hour. That's because I've got miles is the only thing left on top and hours is the only thing left on bottom. All those other numbers are needed there to convert. Okay, so if I go to my calculator, I type in 12 times 60 times 60, I get this number here, 4,320. If I divide that by 5280, I get my answer, 8.18. So as you can see, to the nearest whole number, that is going to be 8 miles per hour. All right, that's all I got for you this week. Thanks for being here. If you have any questions, feel free to email me, justin@tutoring-solutions.com. Thanks a lot.